rays. Is the fact that they're missing from the climate modeling, and part of the equations is because they don't understand cosmic rays enough, or because it won't work with their hypothesis?
Let us say that right now they don't have the equations, so they are in the impossibility of implementing that information inside the model. So then I don't think that, I cannot say that there is a political agenda, so people don't even consider the situation because of their political agenda. I believe that, so it's very simple. So
okay.
The equations, the physics does not yet exist,
okay.
and they don't put. The problem is that they should tell it, so that is what perhaps should be, so the people should be informed about that. So that is probably their, so what should be said more often.
Okay, go to your other point you were making.
Okay, the second point is that the models have another problem, another limitation. The limitation is that these models use a kind of cell. So practically, they cannot model a very small region of the Earth. Okay, so what they do is to divide the entire world, the entire atmosphere, in cubes, in little cubes, right?
Okay.
And each cube is a unit. Now, the unit, the size of these cubes is very big. It may be 100 miles and more. Okay, and the clouds are much smaller objects, and therefore there is another limitation about that. So they are not able to fully model cloud system because the clouds are a too small object compared to the resolution of these models. And so this it essentially is another limitation that tells us that these models essentially model very poorly the cloud system. The cloud system can regulate a large amount of energy, the energy that enters inside the climate and reaches the Earth. Therefore, as a consequence of this large uncertainty, the climate models present a huge uncertainty. So, for example, I may ask you a question. So people are talking about CO2 as something that changes climate. But I would like to ask you this question: do you know how much is the uncertainty about the effect of CO2 on the climate?
The only thing I've learned about CO2 that I can say with clarity is that carbon dioxide acts as food for all plant life.
Exactly. So that is another issue. But let us address one issue by time. Okay. So first of all, what is the uncertainty associated to CO2? So if we double the amount of CO2 in the atmosphere, how much the temperature goes up? Okay, so that is the idea. Right now, the models, the climate models and the studies that are done are very uncertain, give a very large uncertainty. So some studies say that the temperature will rise just 1 Celsius degree. Other studies say that temperature may rise 8, 9 Celsius. So practically there is a very huge window, okay, between 1 and 10. The center of this window is about 3, but you understand that there is this huge uncertainty. So the people do not even know exactly what the CO2 is doing to the climate, because if we double the amount of CO2 in the atmosphere, the temperature may rise 1 Celsius, 2 Celsius, 3, 4, 5, 6, 7, 8, 9, or 10. So Celsius degree, so the people do not even know.
But what does that mean? I want to bring you back for a moment. I know you're in the midst of explaining it, but Nicola, what does that mean then?
That means that the error implicit in the climate models is much bigger than the signal they want to interpret. The signal is the temperature. So this temperature is present patterns. The temperature goes up and down, and the error associated to these models is much bigger than the signal. Therefore, the model cannot efficiently interpret the signal, so interpret the temperature.
Basically, the models are making such huge errors because they can't interpret the temperature, period.
Exactly. So practically what happens is that if we imagine that the sensitivity, the climate sensitivity to CO2 is the low limit, is 1 Celsius, as I told you before, the model would not produce any warming during the last century. Instead, if we assume that the sensitivity is, like, for example, 10 Celsius, the model would produce a warming of 3-4 Celsius during the last century, while what is observed is less than 1 Celsius. So practically, we go from 0 to a number that is 3 times, 4 times more than what has been observed. So this is the window, the error window implicit in the models used in the IPCC. Therefore, those models have a too big error to be really efficient in interpreting climate systems.
Do you think that climate modeling is a totally inefficient way to look at the future for climate? Is that what you're saying?
I believe that those kind of modeling are not efficient. So the modeling that uses computer programs that model all little mechanisms. They try to model the complex system starting from all little mechanisms. Okay, so that approach is not efficient because the error would be too big. It's like, for example, if some physician would like to interpret the physiology of a human by using a computer model. So that is the issue. So it's evident that the complexity of the system is such that it is not possible. It would be not possible for a physician to model the entire human body, so human physiology, by starting from the cells, from the blood flow, so by writing a computer model that try to reproduce the dynamics of the entire system. So it will be inefficient because of the lack of detailed knowledge and of the chaos and of so the uncertainty will become bigger and bigger and so on. So I believe that is the approach that is used that is not efficient, because that approach implies errors that are so big that essentially do not allow the people to correctly interpret the climate system. So that is. So I need to use another approach.
Okay, so what do you recommend?
Well, the approach is very similar in some sense. Let us say it's very similar to the approach always used, actually. So let us start with a very simple example. Historically, so since ancient times, the people were trying to interpret climate by studying the geometrical pattern of the climate. So imagine, for example, the ancients. The ancients were creating calendars. Calendars were instruments for forecasting climate, right? So they forecast summer, winter, so So they will say in 6 months there will be winter, in 6 months there will be summer. So they were a kind of very simple instrument for